I want to move down. So I want to take the derivative of the exponential function a to the x. So let's try the same tact as before. Let's write this as y is equal to a to the x. And I've got a couple different tricks I could try here. In this case, I'd like to write it as, I'm going to take the natural log of both sides. I'm going to say that the natural log of y is equal to the natural log of a to the x. This gives me a chance to practice some of my properties of logarithms. So what can I do here? Well, I can pull this power of x that's being multiplied to the whole base of that exponent. I can pull that out of the logarithm as a factor. So at least with the natural log of y is equal to x times the natural log of a. It's important to remember here what are variables and what are numbers. So y is a variable. It stands for the dependent value of this function. X is a variable. It stands for the independent variable of this function. But a in this case is just a constant. So in fact, we don't usually write functions that way. Usually we lead with the constant. So I'm going to take one more step to rewrite this as the natural log of y is equal to the natural log of a times x. So finally, at long last here, I'm ready to take the derivative of both sides. I'm going to take d dx of both sides. So we take d dx to the left, and then the right. Okay, and I'm running out of room here. Hopefully you can still fit this in. So on the left-hand side, I'm taking the derivative of y, or excuse me, I'm taking the derivative of the natural log of y with respect to x, and that is 1 over y times y prime. How come? Because the derivative of the natural log of an expression is just 1 over that expression times that expression's derivative. So we've got to use some implicit differentiation here. Now, be careful on the right-hand side, folks. Okay, we already said this. Let's say it one more time. The natural log of a, that's just a constant, because a is a constant, so that's just a number. So I've got a number times the function x, and the derivative of a number times the function x, that's just the slope of that linear function. And so what's its derivative? It is the natural log of a. So we're trying to find y prime here. We end up with y prime is equal to the natural log of a times y. What was y? Well, we're turning all the way back to the original statement. Y is a to the x, so we get that y prime is the natural log of a times a to the x. Okay, well, let's quickly work a couple of problems with that. Here I'm asking you in number 26 to find the derivative of 100 to the x plus the natural log of x, or excuse me, plus e to the x plus pi to the x, and we're going to find the derivative of that expression. So we get that j prime of x is equal to the natural log of 100 times 100 to the x plus the natural log of e times e to the x plus the natural log of pi times pi to the x. Clear up some space here for us. So times pi to the x. There's not really much cleaning up we can do. I'm going to rewrite this as the natural log of 100 times 100 to the x plus e to the x. Notice that that fits with what we've always said the derivative of e to the x was, right? We've always said the derivative of e to the x is e to the x. Here, though, I treated it as the exponential function a to the x, but I get the same answer once I simplify it. And then for the last term, we get plus the natural log of pi times pi to the x. So take a look at this problem, maybe rework it if you need to, and let's work the next one. Here we get that y prime is equal to, so this would be the natural log of the base times 2 to the 3 plus sine x. But then we've got a chain rule up here because the expression up here was more complicated than just an x. So I'm going to multiply this by the derivative of 3 plus sine x, and the derivative of 3 plus sine x would be, I'm going to go ahead and emphasize this, I'll put 0 plus the cosine of x, just to emphasize that chain rule. Okay. So that was the derivative of the first term. Now I need to take the derivative of the second term. Well, the derivative of sine 2x, in this case we've again got a chain rule. We've got 2x nested inside of sine x. So the derivative of the outer function will just be the cosine of 2x, and then times the derivative of the inner function. And the derivative of the inner function is the natural log of 2 times 2 to the x. So I'll let you try the next two problems on your own, and that will be it for your pre-work for the next class period.